Yeah, so I'll just say that this work was done with a few collaborators, Kenny, Lisa, Will, and David. And what's interesting about this group, that it's a combination of computer scientists, political scientists, and sociologists, and I think it will reflect in what I'm going to present. So here is an overview of the talk. I'll start with what's stance classification, why it is challenging, and I will talk a lot about context in not exactly the same way like the Netflix context, but obviously there are similarities. I will use a case study from United States politics, and then I'll talk about the algorithmic solution. So the main problem, like there are two main problems that I'm going to talk about here. One is very specific, is about stance classification, how we can do that, but really the main thing that is interesting about the work I'm going to present is how to properly annotate data when you have very complex set of context, and it's not clear how which contexts are the right one to choose when you annotate, and obviously you can't do all of it. So just a bit about me. I'm heading the NAS lab. NAS is Natural Language and Processing and Social Dynamics, and we care about the language processing part, but we want to model the language or do the processing based on the social context, who's talking to whom and why, etc. What's not going to be in this talk? So I'm not going to talk about deep learning. You hear this too much. Okay, and there is later session and the previous sessions, etc. It's not going to be exactly about prediction. I'm going to go talk about the other side of the pipeline, or how to properly do the annotation in order to facilitate, or in order to, so this annotation could be leveraged for the prediction task that you're going to use, whatever machine learning algorithm you want to use. Obviously, we're going to have a lot of learning here. Because as I'm going to show, the annotation is complex and will show a nice way to do it cheap and efficiently. So there will be some nice graphical model, and I'm going to show how it improves the annotation process. Okay, so what's stance classification? So in very broad terms, stance is just some kind of generalization of sentiment analysis. People were talking about sentiment analysis still like 2-3 years ago, and if you look at conferences, we now talk about stance. Because sentiment is about what's the sentiment of a specific text. Can say, I really like this movie. So this is a positive sentiment about this movie. And when I talk about stance, is what's my position as a speaker towards something bigger. And so if I say something like, I don't like Trump, for example, it may mean that I like Hillary. It may not, but let's assume that's the case, okay? So the sentiment could be negative, but it implies a positive sentiment towards something else, okay? So that's the main difference. So here is an example from Twitter, from the presidential campaign about 2 years ago. Someone is retweeting someone, and it says Donald Trump is explaining how he will help African Americans by bringing back stop and frisk. That's from a debate. So what we want to do when we do the annotation task, we want people to choose if this tweet supports Trump or opposes Trump, okay? And the reason we ask it about Trump is because Trump is mentioned here, but we could obviously ask the same question about Hillary, and we did that, etc. Okay? So let's see why this is interesting. Okay, so here is a tweet again, and let's do a little experiment here, even though it's dark. Who thinks that this user supports Trump? Raise his hand or her hand. That's like 3, 4, like very few. Okay, who thinks it's neutral? Even less people. But you're all shy or hungry, so you can't lift your hands. And who thinks it supports Trump? Oh, I asked that. Oh, who thinks it supports Hillary? I'm sorry, or against Trump? Okay. So it was about equal, by the way. Like not very many people raised their hands, but it was about equal. Okay, so here is what we found when we did an experiment. Okay, annotators think it's neutral or opposes Trump. Okay. You probably didn't raise your hand because you're not familiar with stop and frisk. So I will explain that, and it is a concept that is a bit clearer to American users, I would say, definitely if they're politically aware. So stop and frisk is a policy that started in New York City in the 90s. And it allows police officers to physically search suspect based on some vague or some vague but maybe probable suspicion, okay? Obviously what happened, and it went beyond New York to other states and other cities. Obviously most people that were profiled this way were minorities. There were a lot of demonstrations, and after about 20 years the Supreme Court ruled it unconstitutional, so stop and frisk policy was kind of banished. Obviously after this tweet, not the tweet, like the statement by Trump, you could see on Twitter things like that emerging, that reaching out to minorities like in a very physical way. Okay, so stop and frisk is a policy that is, at least the common knowledge is that it's very bad for minorities, for African Americans. Okay, so let's do that again. With a context this time. I'm giving you a context and I tell you the guy who tweets that is a registered Republican. Okay? So what do you think now? Is it neutral, just like before? Who thinks it's neutral? Who thinks he supports Trump, the guy? Okay, more hands are up here. Who thinks it opposes Trump? Less hands. Okay, so in our experiments we also see that from these were without any context, these were the results. With this specific context, we get this spike. By the way, we get this real data from the DNC. If everyone's talking about the data about Cambridge Analytica and how to collect data and what people preferences. So we actually got data on millions of voters from the campaign of the Democratic Party, actually. But both parties has that, it's data. Some of it is really public because if you're registered to one of the parties, it's on record. And all the parties use all these tools to gather data, like Cambridge Analytics, not only Democrats, not only Republicans, okay? So I'm going to give you another context. You could think of the context not as what I know about the person, but look at his previous two political tweets. So here he says, again in one debate, Trump said his taxes would have been squandered on roads, on veterans, on police protection, on defense. And this political tweet, Trump is badgering and interrupting. How is that working? From different debates. Okay? And when we see that, we ask people, so there is a major shift to the left. To the left means that saying that this guy who tweeted basically these three tweets, or retweeted these three tweets, opposes Trump, okay? So what we saw here, that there is a very sort of allegedly very simple task, which we do in every day, like we annotate data or we use annotators to prepare data for our classifiers to learn, but giving different contexts, and all of them are plausible contexts, right? It's very reasonable to look at these contexts. We get very different pictures, like really radically different pictures. And we want to account for that, okay? So again, if you see, I'm not going to go over all these details, but we see that providing context, no matter what context, improve agreement between annotators. But again, it introduces bias, so it throws all or most of the annotators to some specific direction, which is not necessarily the right direction. Or at least its direction is very different than giving other context. Okay? And we could think on many contexts, and we tried them, and you see very similar results, sort of. Okay. And obviously, if we use some context and we believe that our annotation is good because it's coherent, there is high agreement, etc., we're going to build our system around it, and we're going to get great performance, but it will probably not catch what we want to achieve, right? So we have a nice algorithm that works with all the measures, but it doesn't measure the right thing, okay, the right signal here. Okay. So what are we doing? Ideally, we would like to just have a perfect annotation, right? So we're going to have very committed annotators. We're going to maybe pay them a lot. We're going to tell them, okay, read the whole timeline of the users we want to annotate, read what they write and their bio, and check if they have LinkedIn, and look at their friends and who they're retweeting and who they're friending and who they're liking, etc. And we'll have kind of a perfect picture of the guy, and this will be our annotation. Obviously, this is impractical for many reasons, the cognitive overload, the time it takes, etc., etc. We cannot do that. And maybe most disturbing, it's still ill-defined, not is-defined, which we still don't know what maybe we're missing from the digital traces. We may be missing some important context. But what we can do, we could work with what we have. And we have 3 stages here. So first I'm gonna call it like annotation boosting, okay? So first we're gonna use many mechanical Turkers to annotate many simple contexts. So these tasks are very fast, very cheap, okay? We're gonna use a model which I'm gonna go into some details in future slides, in the next few slides about this model. That models both the context and the annotation and the data that we actually see. And then we simultaneously going to learn 2 things, basically. We're going to learn the true label, and this is in parentheses because the true labels are kind of an estimation of the true labels. We'll see how we do that. And we're going to learn also, sort of a side effect is we're going to train a classifier. And we also going to learn like the quality of the annotations and context, or not the quality, maybe the bias of each annotator and each context. So just about the setting, we use about 500 users, 562. We pick one political tweet as an anchor tweet, which this is the tweet we present to everyone. And then we pick a few different contexts. We have different annotators. Basically, each pair of context and the anchor tweet got at least 3 annotations, which means every anchor tweet actually got at least 21 annotations. We also had development set, and we had a test set. But this is the general setting. And here is the model. So what we assume here, like we have these components, which I'm going to go one by one. But I think the main thing is to understand that we have a classifier, which could be any classifier. It's plug and play. We tried a few. They gave us similar results. And if you have a better classifier, you could just plug it in. It will work. The point in this work is not about finding the best classifier or devising the best classifier. It's about somehow leveraging the many cheap annotations in order to create sort of a true gold standard without really having the gold standard, okay? So what we really care about is this part, but in order to learn this part, we also have the context and the annotators, okay? So here is what's going on in the standard setting that everyone basically does, okay? I have some feature vectors, that's here. I have true labels that I want to learn, or I want to learn by. I have a classifier, and I'm going to train the classifier on these labels in order to reproduce the labels on a test set, okay? This is what usually goes. How are we going to get the annotations? We're going to just throw some very simple annotation task, and we do either majority vote because we think that our context is best, and our annotators are great, etc. Nothing complex here. Then there is a very nice work by Riker et al. From some 7 years ago, 8 years ago. And what they care about is we know that annotators differ in quality. Some annotators are good and observant on whatever data they're annotating, and some other annotators are just, they just suck. They are not doing it on purpose, but they're just not good. Definitely not for a complex task or tasks that are, a bit. You need to carefully assess what you're doing, okay? So they propose a model which they add this part to the model. Okay, this is grayed out. It's not grayed enough here. So this is the vanilla model, the standard model. This is what Riker et al. Introduced, which is kind of an annotator bias model, and they aim at learning, like assigning a weight to each annotator in order to improve the total annotation, so you could weight better and not just do majority vote. And what we add in this work, we add this part, okay? So we actually model this whole box. So the generative story is like this. We have a classifier, whatever classifier it is, okay? You just choose the classifier. we have the data with the features, with the context, again, whatever. There are some true labels, like there are true labels, in fact. We don't know them, they're latent. Once we introduce context, so now the labels are labels of users by context, not only by the regular text, it basically introduces kind of a bias, okay, into the labels. And again, we also have now annotators annotate the data with the context. Again, each annotator introduces some bias to the kind of fake label or biased label that kind of thrown on by the context. Okay. Now, each of these parameters is actually a matrix or a transition matrix. That what it's doing. The transition matrix is kind of reshifts the bias that is introduced by the context and by the annotators to the right direction. The overall mechanism that we use here to learn is like by expectation maximization. The derivation of that is pretty complex, many details, so if you are interested in that, just check it in the paper. The paper was published in the last year's EMNLP, and there is also code, you'll see that in the last slide. And now to some results. Okay, so I think I talked about that. As I said, we don't have enough data for any deep learning, and again, it doesn't matter. The classifier is not the point here. The point here has to create the gold standard for the classifier, so we tried these classifiers. They were pretty much the same. Random forest were the best, but again, you could plug in any classifier you want, and the results. Okay, so if we use the classifiers, and these are the results for the best classifiers, based on majority vote. So this is a standard setting. I have the tweets, I have the context, I have annotations. The annotation may contradict, may not. I do majority vote on the labels, and then I try to learn from the majority vote. So here is the agreement given the context. So you could see that political tweets and political party bring very high agreement. We also saw that in the bar charts that I saw. There is a log loss. Like the least, the better. There is a F score, the highest, the better, and you could see this is the result. Again, the basic classifiers based on majority vote. Okay, I didn't do anything interesting about how to choose a label. I did majority votes on the labels, and I tried to learn from that. When I take the best log loss and F score from these baselines, again, they could be strong classifiers, and I compare it to what I achieve by constants, which is the algorithm, the graphical model we introduced here, we get a much, much better log loss, and we get a much better, again, average F1, which means that we managed to leverage the many cheap annotations, not by just doing a simple majority vote, but by actually learn the weights for both context and annotators, or actually annotators for context, and we just get better results for classification. Ablation, I'm going to skip that. What? Yeah, that's. I'm just going to say about this that we can look at this transition matrix and learn something about the different context. I'm going to skip that. I'll just say that if you see the darker color here, like if you have only the diagonal, it means that there is no bias, okay? You learn exactly the context, and the real label is exactly the same. If you see some darker shades not on the diagonal, it means where the bias is going to, if it's going towards the neutral or towards the extremes, etc. And I'll just, final slide. So again, picking the right or the sufficient context is hard. It's domain dependent. We are not expert in that. We may think that we did it right because we see high annotator agreement or even sort of high classification results, etc. And we proposed the constants, which is cheap and fast and efficient, and it improves results. And we don't need to care so much about this data, this bias, and our lack of understanding of the domain. And again, this approach is not only for sentiment or stance classification. It's general for every tasks that we have many contexts and it's complex and we don't know how to choose or how to combine the context for annotation. And with that I will conclude. I stole this image from you. I added here, like I did like a screen grab with with the intellectual property right here. If you want code and data, you could find it here. Questions you could ask now or email me. And that's it.
Unfortunately, I cannot ask now, but you can ask later.
Okay, so thanks.
Okay. למה זה לא עובד? Okay. So, thank you very much, Oren. As I told you before, you have to ask him questions later in the break.